In this video, we're going to look at transformations of functions, and more specifically, transformations of linear functions. All right, just looking at two different graphs, we have g of x and we have m of x, these two different functions. Notice the first function is 1/2 x plus 7. The second function is 1/2 x plus 4. The main difference here is the 4 and the 7. And notice how the graphs, I've graphed both of these, and how it looks different. So they have the same slope. So we know that they're increasing, in this case, at the same rate. We know if we put these on the same graph, they would be parallel. And the only difference here is that the y-intercepts are different. So we would say that m of x has been shifted down, and it's actually been shifted down 3. So here the y-intercept was 7. On m of x, the y-intercept is 4. Same slope. So we'd say that this is m of x is the original function g of x, but we've shifted it down 3. The next one, I put these on the same graph. Notice the y-intercepts are the same. This one has -1/2 x, and this one has 1/2 x. So the slopes are different. One's positive and one's negative. If this is the case, basically what we're saying is that this has been reflected over the y-axis. So each of these points has now been reflected straight across there. So if we folded this in half, essentially this would create a line of symmetry. So that is when the slopes are the same value except one's positive and one's negative. That would be a reflection over the y-axis. Now, if we're going to describe the difference between these graphs, let's see, 4x and 4x. So slopes are the same, 4. The difference here, one is -5 and one is 7 for our y-intercepts. So we've taken the original function f of x, and now we have g of x. So g of x is f of x, but we've taken this original one and we've actually bumped it up, and we've vertically shifted it up 12 because we went from a -5 as a y-intercept. Now we're at 7. So we've shifted up 12 from f of x. Now we have f of x and we have g of x here. Same y-intercepts. Okay, we have a slope of 3 versus a slope of 3.5. So we've taken f of x, we've kept the y-intercept the same, but now we've made it steeper. Our slope is greater here. So g of x is the function f of x with a greater slope, which means it's steeper. So how did the slope change? Well, it increased, and if it increases, then the line becomes steeper. Our last example, we have +7, +7. Those are our y-intercepts. Our slopes are -7/2 and 7/2. So what we've done is we've reflected it's been reflected across the x-axis, or sorry, across the y-axis. Because these slopes are the exact same except one's positive and one's negative. That negative, changing that sign, shows us that it's been reflected. All right, now we're going to be writing a new equation. So given an original function, we write a new equation. So we want to write g of x. That's the original function, f of x, shifted down 10 units. So our original y-intercept was +7. If we go down 10 units, we're going to go down 7 to 0, and then we're going to go down 3 more. So our slope is going to stay the same, but our y-intercept is now going to be -3 because we went down a total of 10 units. we have this original function. We want to write a new function h of x that's f of x reflected over the y-axis. So the main thing that's going to change here, the positive 7 is going to stay the same. The y-intercept is going to stay the same. The main thing that's going to change here is the slope. Instead of 3x, it's going to be negative 3x, showing that it's been reflected across the y-axis. The last thing that I want to show you is parent function. The parent function here is the most basic function that we have. And for a linear function, it is y equals x. That is the parent function.